I'm at Cliff Mine in the Keweenaw Peninsula of Michigan, probably the most accessible tailings pile in the state, if not in the country. It's owned by the Keweenaw County Road Commission, but they welcome the public, and it is just off the road. It is one of the oldest mines in the area, a copper mine, and just a wonderful place to visit individually or with your family. I'm Craig the geologist. Come check it out with me. Cliff Mine is located about 15 minutes north of Calumet, Michigan, and holds an official distinction, awarded by myself, of being the most accessible tailings pile and most accessible rock counting location that isn't a beach in all of the Midwest. Now, there are many other locations. In fact, there are probably several hundred tailings piles in the Keweenaw Peninsula just around this area. But while some of them have better material, none of them are as accessible as this one. They are either on private land and you have to negotiate with the landowners, or they're on county land, and in some cases, such as Houghton County just to the south, they will literally chase you off and call the cops on you for trespassing on county land. Keweenaw County, on the other hand, at least at the time of filming, is fine with you visiting these locations to collect as long as they don't have any equipment of their own on site that you're going to interfere with. The Keweenaw County Road Commission owns this location, and they allow it to be bulldozed once a year for the Keweenaw Mineral Days, and they never have equipment of their own out here. It is always accessible, rain or shine. Now, what you're going to find here is a ton of native copper. This is probably the best place in the world to easily find native copper. You're going to find Isle Royal greenstone out there. There is some dadolite and pretty much everything else that the Keweenaw has to offer. Other than that, a lot of calcite and some alteration minerals. It's a beautiful spot. This location can be divided up into two regions: Cliff Mine, which is right on the road and easy to reach, and Cliff North, which has far more beautiful specimens, but is also incredibly difficult to reach. And so we're going to talk about Cliff Mine today and save Cliff North for a future episode, which I visited on this particular day, but is going to be almost impossible for most of you to be able to reach. Well, I'm at the entrance to the Cliff Mine tailings pile, and as I mentioned, it's one of the most accessible tailings piles around. It's just very easy. It's located directly on Cliff Drive, which isn't always the easiest road to find, but it is a partially paved road with sections of washboard and rutted dirt road intermingled. You can see all these cars parked out here. And the entrance is simple. There's a gate to keep vehicles out, but you are allowed to walk around it. It's a publicly accessible site. And the piles are just behind me back here. And you can probably see behind me also why they call this Cliff Mine. The cliffs are all back there. Now, there is a little stream that runs along here, and a very rickety old little bridge over here that can be tricky to find. Got a little overgrown this year, so it's extra hidden. But here we go. In case you don't want to walk through ankle deep water, there's this. It gets worse and worse every year, and I'm sure eventually someone will put a new piece of wood out here, but it holds my heavy weight, so I'll be able to hold most of you. And that's it. You're on the tailings piles. There's two main ones here, one on the right and one on the left. About a week ago, one of the mineral clubs bulldozed these, removing the top layer and exposing some fresh material for everybody. And of course, in the days that followed, everybody was up here with metal detectors trying to pick everything clean. But there should still be some good stuff. I mean, you can come out here any time of year and find stuff. No matter how many people out here picking, there's always more to find. I think let's go up the left one today here. You can see the path the bulldozer took. Kind of makes a path for us. It's more convenient. When given an option between walking up a tailings pile on a bit of a path that vehicles have previously taken like this, or scrambling up the side, say over there, please always choose the easier route. I've slid down a lot of these things. I'm kind of an expert at falling down them. I don't usually get hurt, but a lot of people do. So why risk it? Here we go. Well, despite all those cars out there, looks like we got this pile all to ourselves. Here we go. That's a lot of rock to search through. Of course, there's a beautiful view of the cliffs right behind it there. And up at the top of those cliffs is Cliff North, where we'll be going later today. I will be happy to bring you along up there and show you what it's like. Got some ridges left by the excavator, by the bulldozer. And over here we've got the edge of the pile. Down at the bottom below me, I just saw a nice family wearing Crocs. Please never wear Crocs or sandals or flip-flops on a pile like this. Value your feet. You need them to walk. Don't destroy them by wearing open-toed shoes out here. That is a big giant no-no. Here comes my assistant with bags of snacks. No, I'm good, thank you. All right, well, I was about to start showing you guys some of the stuff you can find out here. Joey already found a rock that is orange and he wanted to know about it. Well, the orange color, kind of pink, maybe salmon color, maybe that's the most accurate description, is probably a mix of feldspar and or zeolite. And the zeolite mineral that is really dominant out here is heulandite. And as for the material inside, I think that's just basalt. It first caught my eye thinking like maybe it was calcite, but I think that's basalt. Here you go, give you a rock back. I'm good, thank you. Thank you for offering me that cookie. Let's take a close-up look at some of these at an angle where I'm not catching too much shadow from the selfie stick here. I do my best to film this as professionally as possible. Here we go. Here's a beautiful piece of what is probably calcite. Sometimes it's real obvious that it's calcite, sometimes it's a little less obvious. The vast majority of these rocks out here are are basalt. Of course, copper is what they are mining and looking for out here. But these black rocks, they are all basalt. These rocks are full of copper. This is oxidized copper in here. Let's turn this so it's catching the light a little bit better. There we go. That's oxidized copper in there. Oxidized copper is malachite green. It is the exact same green as the Statue of Liberty. Statue of Liberty was bright, shiny copper when they first delivered it to the US from France. And within a couple of years, it had turned that green color that copper does when exposed to the elements. We'll use that knowledge to look for that Statue of Liberty oxidized green when you're out here if you're looking for copper. pretty much everyone who comes out here is looking for copper. There's some calcite mixed in with this basalt here, in case you were wondering. Now, I do bring a metal detector out here nowadays. First 20 years of my rock hounding, I never really bothered with that. But I do try it now. It's handy for finding chisel chips beneath the surface, and I'll describe that and show it to you in a little bit. Not sure if we'll be successful or not. I have a pretty low success rate, but that's all right. I find the effort to be as much fun as the finding. As I've said before, the finding is more fun than the having. Got here. Oh yeah, we got some zeolite minerals in there. Zeolites are, generally speaking, decay minerals. They are minerals that began as something else, but over time, the elements, the wind and rain, this can happen beneath the surface too, just from groundwater. It works away and eats away at the minerals, and they break down to clay. And on their way to clay, they take a little pause at the zeolite minerals. Besides copper, other minerals you can find out here, you can occasionally find Isle Royal greenstone. Usually not amazing specimens, but you can find a little bit. It's a little copper clinging to this piece here. You can find some really nice calcite pieces, honestly. I've found some great ROMs of calcite that I've taken home and shared with other people. And of course, if you're just a casual rock hound, there's all sorts of pretty rocks with interesting patterns that you might enjoy. The chisel chips are a big one though that people really like. Looks like we got some calcite here again. What'd you find there, Joey? Oh, have a look at that. All right. Well, let's talk about it a little bit. First of all, there we go. The camera was focusing on my son, who's pretty handsome. I can't blame the camera. But we've got some quartz crystals on here. And that green you see is prehnite. Now, prehnite, when it's real nicely formed and intact, can be botryoidal and bubbly. It's just gorgeous stuff. This is kind of massive, although I do see, I wonder if I can get the camera to focus in there, a bit of bubbly material kind of tucked away underneath that quartz crystal. Can you see it there? That's pretty cool stuff. That's actually a really good find, Joey. I was just keeping that if you wanted to. Well, hello, and here's my other assistant. She's up here. She and Mickey will be doing all the grunt work for me. Did you find something? You're slipping and falling? Yeah. Oh, here we go. There we go. Here's a very nice piece of calcite my wife just found. I was talking about finding those nice pieces of calcite out here. Look at that beautiful crystal of it there, just sitting on the surface. That's so cool. There may be a little extra background noise in this video because I'm with my family, but honestly, if you've got family and they're willing to come out with you, that's the best way to do this. It's so much more fun. That's a great find, honey. When constructing mine dumps, the original mine operators were super lazy. Fact is, you move the waste rock as little as you need to because it's heavy. It's a lot of work to dump it somewhere else. And so you tend to dump it right next to wherever your mine is. Not close enough that it's gonna, slow down or inhibit mine operations. You don't want that, then you're just shooting yourself in the foot. But just beyond that point, you don't move it any further than you have to. And so these mine dumps, they usually just found a low spot somewhere that they could just fill in. That's what you have here. This is all wetland around here at the base of the cliff. And it's like, hey, here's a low-lying piece of land right next to our mine, which they built into the side of the cliff, and just dump the rock right next to it. And you'll find that's the case at every mine dump. Every mine dump is located right next to wherever the mine was, just far enough away that it didn't inhibit operations, but you know, as close as they could make it. All right, my son found this little bit here. It's got some epidote on there, and you can find a lot of epidote out here. And then this piece here, he handed it to me like this. I'm like, well, that's nothing, but you turn it over and there's some nice calcite on there and a bit of purple color mixed in. I'm not sure exactly what the purple is in every case, but that's awfully pretty. Here you go, Joey. And what do we got here? Oh, here we go. My wife found our first piece of copper for the day. So this is what you're looking for, and it's proof that you don't need a metal detector to find copper out here. This is not a chisel chip. It's too thin to be a chisel chip. Although it's the right general shape, but it's just too thin, too small. It's not, I don't think. But you're looking for that oxidized copper green. You know, like I said, Statue of Liberty green. I mean, look at the shape. That's not a normal shape for a rock. Rock is brittle, and it doesn't like to have little prongs coming off of it. Those tend to break right away. And look how thin that is. Like I said, rock is brittle. It doesn't like to form long sheets like that. That's metal there. So the metal that they mined, oh, there we go. And just that quickly, my wife found another one here. We've got metal running all throughout this one. Copper. This is mostly rock on here, but it's got a lot of copper clinging to it. It's not just a dusting of oxidized copper. This is actual, you know, sheet copper running through there. So there are several types of copper mines out here in this area. And you will find words like amygdaloid on street names around here. The amygdaloids are basalts that were amygdaloidal. They have amygdules in them. And if you don't know what that means, you should be watching more of my videos. But the amygdules are gas bubbles in the lava that froze in place, and those gas bubbles filled in with minerals and often filled in with copper. Those are the easiest to mine. But the very first mines that went up in the area were chasing the sheet copper, which the early geologists, I believe Douglas Houghton, warned against doing. They said, hey, you know, it's enticing, it's a lot of copper all in one place, but it's really hard to get out of the ground. Well, you know, when people saw giant sheets of copper coming out of the ground, they had dollar signs in their eyes, and they built the Cliff Mine to chase those sheets of copper. And so the sheets of copper they extracted were enormous. I mean, just behemoths. But you do find sheet copper like this all over out here. You won't find amygdaloidal copper at this site, but you'll find sheets of copper. Nothing super thick, but thin sheets out here. You know, the copper you find out here is the stuff that they missed when the mine operators were collecting all the copper. A lot of smaller pieces ended up in the scrap that got dumped, and that's what you're finding out here. So apparently, while I talk, my wife is just gonna find all the best stuff out here for me to show. So hey, you know, teamwork makes the dream work. I'm not gonna lie, I'm loving it. So first of all, she's got a piece of calcite here that is awfully pink. I hope the color's being caught on the camera here. It's kind of a yellowish pink, maybe an orangish pink, but it's definitely pink. You do get pink calcite out here, and it's pink because of an impurity in the calcite. And if I can look up what that impurity is, I will share it with you right now. And if not, I'm just gonna leave it at that. It's an impurity of some kind, but it's pink calcite. Right here, the green is prehnite. This is really shattered. The original stuff was probably gorgeous before they, you know, hit it with dynamite. But that is a lot of green prehnite right there. Beside it, looks like calcite based on the cleavage. And every time I give her her rocks back, she hands me more to show off.
I don't think this is anything, but it's just interesting. So shiny this is.
Yeah.
Like a super shiny surface.
That is shiny. You do find shiny, sparkly stuff out here. What it is teeny tiny crystals reflecting the light on this.
Oh,
And what those are, I'm not sure. I have to break out a hand lens or possibly even a microscope. And I'm just not curious enough to actually do that. But this is a piece of basalt that's just a little bit more crystalline in nature than the others. Okay, here's a little blocky something here. That is interesting. Well, that's definitely calcite. You can see those tilted cube faces there at the rhomb. Very rhombohedral from the way that broke. And so that's your diagnostic feature there. Hey, if you're not good at identifying calcite, you should have already watched my video on identifying calcite. Give it a watch. Check the corner of the screen here. Ooh, well, that was fast. Here's another piece of calcite. This was a little bit more weathered, but certainly bigger and blockier. That's interesting. I like that one. Looks like we got a couple of calcite crystals kind of twinned onto each other there. Twinning is where crystal is growing in one particular way, and then due to some defect in the crystal lattice, a second crystal of the same material kind of grows off of it at an angle. You can probably see that happening here, I hope. Even without being a geologist, I think you could probably see where you have a large crystal on the left and a smaller crystal growing off of it on the right at an angle. That's pretty neat. That's going in my pocket. What do we have here? Oh, we got some layered rock here. So these rocks, oh, looks like we got maybe some quartz crystals in there, little ones. These rocks underwent some metamorphism. The hot water that emplaced the copper also did a number on the rock in places and turned the basalt into epidote in some places. So what you're seeing is some epidote alteration along with some copper. I'm definitely seeing a lot of specks of copper green in this as well. So we're seeing altered basalt with copper. So those hot waters that carried the copper also tended to alter, basically cook the basalt and convert some of those minerals in it to epidote, which is what you're seeing here. It's a beautiful little piece. I'm going to leave it here for somebody else. Oh, hey, what did you just step over there, Joey? What did you just step over there? Is that a nice calcite crystal? It sure is.
Ooh.
Just lying around out here. Yes, you can have it, absolutely.
Yeah, you can't. I can't. It basically looks like a white rock, and I can't really see the calcite in it. But
Well, it's pure calcite, and it forms a crystal like that. It's not clear, it's kind of a milky color like you saw. And but it forms like, it's almost like a square that's been tilted over. It's called rhombohedral. That's a shape you should be learning in school sometime soon. I am still recording. I don't know if I'll use this in the video I post, but I am still recording. What we got here? I see some shiny crystal faces here. Ooh, that's a lot of calcite in there. Yeah, I think we will start metal detecting soon. That's a nice, nice vein of calcite running through there. Oh, geez, you look like you're ready to start surfing. Mm-hmm. at you.
I'm not even using the balance.
There you go, you're well balanced. Should I film you falling off? Oh, okay, there you go. Oh, here's a big piece of calcite right there. I like that one. Probably take that one too. I like to take these and I like to give them away to people. You got a heavy one over there? When they're unusually heavy, that usually means there's copper inside.
I can see a tiny little bit of copper there, but it's still heavy.
Oh, it is heavy, yeah. Yeah, that's definitely mostly copper. Oh, you can see the copper reflecting there. Oh, someone was probably looking for this piece and accidentally kicked it aside with their shovel. But yeah, this is like a whole kind of nuggetish, not really a true nugget of copper, but there's enough copper running through that rock that it's probably as much copper as rock in there. Oh yeah, there's another nice piece of calcite there. Yeah, there's some more nice calcites there. That one's for me. Oh, you got it all wet for me, and it is so pretty.
Yeah.
I'm gonna put it over here by my bag, okay?
Okay, sure.
Thank you so much.
I'm not going to make you patch my inner circle.
I'm gonna set it right here.
Yes, you can do that.
Thank you, thank you, thank you.
If you walk up, you walk on Daddy. I love you.
I love you.
Of your group member came out and actually found greenstone. The Iowa recording now.
All right, now point the camera straight down by your feet. All right, right here. Can you see that? You're really bad at pointing that camera where I've got my finger pointing.
Oh yeah, the green stuff.
You must be able to, oh, there it is, okay. Take a look at that. That is a nice piece of copper.
Yeah.
And you see the way that, oh, thank you for that, Sophie. Yeah, you want to get that on camera? Yeah, I can see that's a good piece. Here's Sophie's piece. All right, now, the copper here. What caught my eye? Well, first of all, yeah, go ahead. You can beat that. Yep. That green color, Statue of Liberty green, caught my eye. Look at the way that's curled. When was the last time you saw a rock curl up on itself, stuff like that? It just doesn't happen. So that is classic metal. That's copper. Very nice piece there. And you were nearly standing on it. Oh yeah, you found that rock's got some copper in it too, for sure. Now, since copper is by far the most common mineral that people are looking for at Cliff Mine, let's take a closer look at it and figure out what you're going to be looking for when you're there looking for copper yourself. This is what the copper specimens look like when they're washed, they're wet. You see that bluish green copper, that classic oxidized copper. When I keep talking about Statue of Liberty green, that's what I'm talking about. This is a larger piece that I'm showing very quickly, just a large rock with a little bit of copper on the one side of it. This flat piece here, you can't really see the copper in it, but it's unusually flat. It feels a bit weird, and it rang up the metal detector. That pinpointer went wild, so this one's definitely got copper inside it. All right, here's what you've really been waiting for. Here are the native copper pieces. Now, this piece here, there's a lot of copper in that. It's very heavy, but it's not super obvious. But for a piece like that, I would hope that that's obvious to everyone that that's metal. I mean, brittle rock just does not make a shape like that. And in fact, you can see the metal copper, unoxidized copper threads running all throughout that. Here you see that Statue of Liberty green I keep talking about. You see a few little glimpses of actual copper color, that classic unoxidized copper in there. And look at that sheet shape. Here you see another sheet of copper extending from the rock. This is a very common look for the copper you find out there. A little bit of rock and a bit of copper coming off of it. Here you see a little bit of the same. Here copper is just running all throughout the rock, kind of wrapping around it in a way. Here is your classic sheet with a bit of rock still stuck to it, but this is mostly copper. And these pieces over here, also mostly copper, much more copper than rock. Let's have a look at that final piece we found. Look at the way that's curving in on itself. There's no brittle rock on the planet that once dynamited will look like that. That has been bent by force. That is metal. Now what do you say? Should we clean these up with a bit of acid and have a look at what they really look like once that oxidation is stripped away? Of course your answer to that question was yes. So, putting on some protective gloves. Usually I wear better gloves than this, but I've recently discovered that I need to do a better job of organizing my house. I couldn't find the better gloves, but these will work. I'm not using the strongest chemicals known to man. It's just some relatively dilute hydrochloric acid and baking soda, really. In front of the camera here are two glasses, both filled with water. Into one, I'm going to pour in some hydrochloric acid. Now you can purchase hydrochloric acid at the hardware store in a much less scientific looking bottle under the name muriatic acid. That's spelled M-U-R-I-A-T-I-C. And that's usually in pool supplies or near the paint section. It's often used for etching brick and cleaning pools, that kind of thing. You always want to pour acid into water, not water into acid. If you pour water into acid, it can explode. Baking soda in the other one. So I've got acid on one side and I've got a base on the other. And I'm making this base way too strong here. You're going to see how it screws up my experiment, and we're going to learn about it together, and we're going to fix it together. Now I'm going to gather up my copper pieces, and I'm going to plop them in gently, one by one, trying not to spill. Now I've taken a 20% solution of hydrochloric acid and poured it into water, diluting it by at least 2/3. So we're probably down to around 5% hydrochloric acid at this point. You can see it does start bubbling immediately when I put it in. This acid is not strong enough to burn you outright if you're just using your unprotected hands. But you know, if you work with acid a lot, you're going to end up with really dried out, cracking hands if you use a lot of acids and bases on them. So I always use the protection. It's just basic common sense. The water is getting murky real quick, not only from the fine bubbles, from the dissolution of the oxidized material on the surface, but there's a lot of dirt that's being carried up in the process as well as the specimens get cleaned. Now we're going to let it just go for a little while. And at some point I'm going to get a little impatient, pour a little bit of it out and top it up with more acid just to make the solution a little stronger. The stronger the acid is, the faster it works, but you also don't want it bubbling very vigorously. I sometimes have a habit of making the acid a bit too strong and then it fizzes all over the place and it creates vapors that when you inhale is really caustic and nasty and bad for you. Anytime you're working with acid, it's always best to do it outside. I'm doing it inside for filming purposes. I'm also using very dilute acid. But yeah, normally I would do it outside, especially if the weather was better. Here I'm adding acid, but I'm about to realize that when I stick my fingers in to retrieve samples later, it's going to be overflowing, so I'm going to have to dump it out anyways. Now I was hoping that this would be more exciting to film. While it was bubbling, it wasn't quite as vigorous or as exciting as I'd hoped for. It just kind of sat there looking green. And so we've sped this way up to move things along. You'll note that green color though. That's the green oxidation that's come off. Now you have to neutralize the acid after you're done. If you don't, or if you're just a little bit lazy about it, then overnight or sooner, your copper is just going to go right back to being green. It's going to oxidize super fast if there's any hint of hydrochloric acid still left, even, you know, on an atomic scale. And so you need to drop it into water, preferably light base. Now you notice I've got a ton of baking soda in there. I'm used to doing this with much larger groups of rocks and much larger quantities of acid. And so I have kind of overdone it with the baking soda. And you're about to see what that results in. You will note the vigorous bubbling from the baking soda solution though. There is a lot of acid that clings to these rocks when you remove them from the acid bath. And so that base is important for neutralizing that acid. You can use regular water. It just isn't as efficient because it does acidify once you add a little bit of acid to it, because water is perfectly neutral. And so a little bit of baking soda is a good idea. All right, let's have a look at our pieces. They've had a little bit of time to neutralize in the base bath. And let's take a look at the finished product. And oh, well, that doesn't look right. It's covered with this orange crust. I was not expecting that. I don't know what reaction that is, but you know, if acid can tarnish a copper specimen overnight when exposed to air, a strong base bath will tarnish copper in a completely different way instantly. And here I'm confirming that, yeah, it's not just a fluke on one or two of these. These all look wrong. So, okay, well, how do I fix this? Yep, back into the acid you go. And we're just gonna give it a few seconds in there. It really doesn't need a whole lot of time. All right, here we are, almost exactly 1 minute later. And I've got a glass of water now that I'm just going to use to neutralize the acid. And we're gonna pull these pieces out and have a look at what they should have looked like after some neutralizing. Have a look at that. That is the untarnished copper. Let's have a look at a few more pieces while we're at it. And you might see the acid spilling onto the table here. Like I said, it's kind of a dilute acid. It's also a very poor condition table. I'm not terribly worried about it. Now, these have only been in the water for about 90 seconds. I will leave them in for about 4 or 5 hours at least, maybe a little bit longer. But yeah, this is how they come out looking. They come out looking like copper, like you probably imagined it ought to look in the first place. That beautiful copper color. I mean, that's the name for the color. I'm at risk of using the word copper too many times in one sentence, but how you describe copper other than being copper colored, right? Now, there used to be a copper bright chemical that you could treat these with after you've removed the oxidation layer. And what it did was, as it was told to me or explained to me, it kind of replaced the top layer of copper with an atomic layer of platinum. And it very slightly changed the color, but it also ensured that it would never, ever, ever tarnish again. That chemical stopped being sold. I imagine there was some sort of EPA or health reason for that. You can find copper bright today, but it's not the same thing that existed 20 years ago. Although I have heard that there are some shops in the UP that have stockpiled barrels of it and sell it to folks who know how to ask. Properly washed though, these samples ought to stay relatively clean looking like this for a few years at least. And if not properly washed, a few months or a few weeks or a few days or a few hours, depending on just how badly you've washed it. And my patience tends to be kind of low, so I tend to wash them kind of badly and then have disappointing results. But back into the water you guys go, and you're gonna sit there for a while. Now that's the end of this episode, but I hope you'll join me next week when I return to Cliff Mine and do a little metal detecting out there. It's going to be a family activity. My son's going to be working the pinpointer while I use the big metal detector. And we're going to see if we can find some better material out there than we could just using our eyes and searching around. Personally, I find it to be a little bit less fun using the metal detector, but are we going to find a lot more stuff? If we do, it might be worth the effort. I hope you enjoyed learning with me today. I hope you'll join me next time. I'll see you out there.